Hi, so in this video, we are going to talk about a new design pattern called as the strategy design pattern. Now, the way I call this design pattern as the runtime selection algorithm. Now, the reason for calling this as a runtime selection algorithm rather than a strategy design pattern is for the sake of understanding. Okay, when I call it as a runtime selection algorithm, I very well convey what purpose does this strategy design pattern solves. Right now, before getting into any design pattern, it's very important to understand why are we even learning a particular design pattern. What is it trying to solve? Now, people look at design patterns as separate entities or separate topics to be learned. But how I see these things as common sense while building softwares. So when you're developing complex softwares, these are very commonsensical things which might occur, which we might feel that okay, certain things should be done in certain way so that it becomes very easy for writing maintainable code and extensible code, right? So when I say strategy design pattern, it essentially tries to solve one very specific use case, right? And what is that use case? That use case is to select algorithms at runtime. Now I will try to give you a real-time example of this, which you might have used without understanding that there might be a strategy design pattern used in the backend. For example, let's say you're making a payment, right? So let's say you're booking a movie ticket, and when you land up on the payment page, you always get an option to select which payment mode you want to select for, right? So you get an option to use the credit card, debit card, or if you are living in India, you also have an option of using an UPI. Now within UPI itself, you have multiple options again, which UPI provider you want to use, whether it's a phone pay, GPay, or Paytm, right? So what you're essentially doing is at runtime, you are making a selection that which payment method of which payment gateway you want to choose, right? So this is one of the very classic example where you are at runtime, you're making a selection. Now, one user might use a credit card option, another might use a UPI option, right? So at the back end, right? So the objects get replaced. So as a client who's making the payment, we are only bothered about choosing which API or which payment gateway we want to choose for or we want to go for, right? But at the back end, this whole thing has been implemented using a strategy design pattern, because this design pattern or this way of designing softwares help us building maintainable and extensible code. Now, for example, what would have happened that let's say tomorrow a new payment gateway comes into picture, right? So it's very easy if you have built a system using a strategy design pattern, then it's very easy for you to integrate such new changes. Or let's say tomorrow onwards the UPI gets banned, right? So it's very easy again to remove the existing features from a system without affecting the other code, right? Because strategy design pattern, or I would call it as a runtime selection algorithm, it gives you the flexibility of isolation, right? So all your different algorithms are running in their own isolations. So what I mean by this is the code for UPI is running in its complete isolation when it compared to the code running for credit card. So when I say code for credit card, it means the code which basically executes the credit card and does the payment for you, right? Similarly for the other modes of payment, let's say you choose a cash on delivery, so the object or the code written for cash on delivery is in complete isolation with the other two, right? So this sort of modularity or this sort of modularity brings in flexibility in your systems, right? Now, if you have understood the use case where this design pattern fits in, then it becomes very easy for me to explain you how we can utilize this design pattern in our code. Now, let's start with understanding how are we going to build our systems in such a way that they're modular and extensible. Let's try to understand what we are trying to do. Now, how do I build such a payment system where all the codes are in isolation and they're modular and such a way that I can add new payment interfaces or payment gateways, and I can remove the existing ones without affecting the others. Now, if you have guessed so far how we are going to do this, then I think you're on the right track. But let me just demonstrate you this using this thing. So essentially, let's say if I want to have multiple payment gateways, right? So what I'll do is I'll essentially put all these different payment gateways into different classes, right? So when I say classes, naturally it means they'll all have their separate object instances, right? So let's say I have a payment gateway over here, which is let's say UPI. So UPI will have its own classes. Then I will have another payment class, which will be let's say credit card. So also so CD is for cash on delivery. Let's say COD. I'll call this COD as a cash on delivery, and then I'll have another one something called as the the credit card. So credit card, so CC, right? So I have three options over here right now. Now, what I want here is I want to have a facility in such a way that my code should be able to choose. I mean, the client should be able to choose among these three options without getting affected, right? So for this, what essentially we do is we basically the client delegates this operation to a separate class or to a separate entity, right? So let me just say that that separate entity is called as the context. Now, I'm using this term from the design pattern itself. So this is just a generic name, right? What we call it as the context here. Okay. Now this context is the class which is going to take the client code or the client request and is going to take the decision that which how should I switch between different objects or different classes, right? So let me also write my client here. So this is going to be my client, which is essentially going to make a request to the context class, and this context class is basically going to choose among these different objects. Now here comes the next question: how do I make these objects interchangeable, right? So if you are aware of interfaces, then you are right, because interfaces is the mechanism by which we make our objects replaceable. Basically, interface is a contract, and if the objects adhere or if the classes adhere to a common interface, then that means that those objects can be interchanged, right? So in order to have this common functionality, I'll have an interface here. So I'll call this as a payment interface. Okay, so this is the payment interface which I have over here. Now all these three classes essentially implements this interface, right? This is how we do it, right? Now this payment interface, since it's an interface, it will have certain set of methods, right? And since all these three classes are implementing these methods, they have to implement their own variations, right? So let's say I add a method called as payment. Let's say there is a method called as payment. So let me choose the same color again here, or let's say I just say call it as pay. So if it has a public class called as pay, so the credit card will also have this method overloaded or will have its own variation. Similarly, the UPI and similarly the cash on delivery, right? And just for simplicity's sake, I'm just keeping a single variable, single method here, but you can guess the interface can have multiple methods and all these classes will be implementing those, right? Now in the context class, right, what will happen is this context class will have conditions like if or something based on certain criteria. This context class will essentially choose among all these three different classes, right? So essentially, for example, if I instantiate a new class for this context itself, let's say I call this as the payment gateway. So here the context class name is as the payment gateway PG. Okay, so this PG or the payment gateway class will essentially choose among these three classes in the backend, and the client will only be aware of this PG class. Okay, so the client, from a client's perspective, these classes are essentially opaque. So basically, the client cannot see these classes in the backend, right? So this is how we are delegating the task from client to the context, right? Okay. Now let us try to, and this is what is all about the strategy design pattern, right? It's very simple. It's not like it's very complex something, right? It might seem complex, but it's really very simple, where you're essentially taking the load of selection of an algorithm from client and you're putting it or you're delegating it to the context class, and the context class internally is making a call which algorithm to choose, which the client has requested essentially, right? So let's say on the fly, let's say the client chooses option one, and option one is credit card, right? So the context class will essentially replace the object with context class. The context class will replace the object with credit card object. So it will have a CC object, right? And using the CC object, you are basically going to make the payment. Let's say on the fly, the client, a separate client chooses the second option, which is to make a payment via the UPI. Now this request also goes, and therefore the context will just replace this object using a UPI object. Okay, so this is how it will going to do a UPI object selection, right? And now the payment will happen using the UPI object, right? So this is how it is. Fine. So enough of talking. I think I should start coding this now, right? And then again we'll come back and we'll see the other things regarding the strategy design pattern. All right, so now let's go through this code. Let's try to understand how I've implemented this payment gateway, right? So now if you look at this, I have written something called as payment method, right? And now this is going to be an interface type. Now for simplicity's sake, I've just taken one method, which is called as the pay, and this is accepting a amount of float 64 type, right? Now this interface will act as a parent class, or interface is basically meant for implementation. So this interface is being implemented by the two different types of payment methods which I have. One is the credit card, right? So in Golang, the way we have classes is using these structs, and this credit card is basically implementing the pay method, right? And if you're coming from Java or C++ background, unlike in those languages, in Go there is an implicit implementation, so you don't use the keyword call as implements or extends and all that for implementing an interface. So the credit card class, or the struct I would say here, so the credit card struct basically implements the pay method, right? It implements the pay method, and by that it eventually implements the payment interface itself. So essentially this class implements this method, right? I would say that if I have to talk in OOP context. But similarly, I have a class called as cash here. Now instead of making this cash, I'll say this as cash on delivery. So I'll say it as COD, right? So this is another payment method. So this is going to be the cash on delivery, right? And this cash on delivery also implements the pay method, right? So essentially we have two modes of payment now, cash on delivery, and the other one is the credit card. I can also have a UPI option, so let's also implement that. So I'll just quickly type. So I'll say UPI, this is again going to be another class, which is again going to be an empty class for now, and I'll simply implement this also. So I'll say UPI, and this is going to implement the UPI interface. Sorry, it is going to implement the pay method, which is from the payment interface. So again, take on. And I think, yeah, so now this UPI is also implementing the interface. Now let me just copy this also. Okay, so now we have three classes, or three different methods of implementation. So now let's talk about implementing the context. Now here my context is the payment gateway. So now this class is essentially going to take the logic, or this class is responsible for making the decision how to switch between the objects, right? The client is not going to do that. The client is just going to give a command or initiate a command that I want to use a particular object or a particular method, a payment method, and the payment gateway will take that responsibility of switching the objects, right? So this payment gateway is the context. So I'll just write it over here. This is the context class which we discussed, right? That's it. Now what else? Now this has a constructor called as the new payment gateway. I know in Golang we don't have a concept called as constructor. We have factory methods which basically instantiate the objects. Technically we don't even have objects in the Golang, but I'm just using these words so that you can relate when you're coming from Java or C++ background, and you can relate that what I'm trying to tell you. So this is the constructor, or the factory method if you want to be very go idiomatic. But yeah, so this is basically doing that. Now one very important aspect that you have to understand when you are implementing a strategy design pattern is that your interface, sorry, your constructor or your factory method, which is going to instantiate the objects, they should be taking the options as a parameters. So if you look at here, I'm passing the payment option as a parameter to this object, or to this constructor, I mean to say, right? This is also called as a dependency injection, right? So we are injecting the dependencies, or here I will say I'm injecting the object, right? So I'm passing the object as a interface value. So if you remember, payment method is an interface. Therefore I can use any of these objects here, right? The objects of these classes: UPI, cash on delivery, and credit card, right? So I can pass these as the options here. Okay, and what it does is it essentially assigns this to the method, and it initializes a name, right? So this new payment gateway will always instantiate a new object containing the payment method, right? Now, and eventually it will also have a make payment, right? Now we have to understand one thing here, that from a client's perspective, now this main function is the client here. The client code will come here. Okay, so this main program will be responsible for calling the APIs. Which APIs? essentially the APIs which are exposed by this context class. So here the context class is the payment gateway, right? So whichever functions I define, for example, make payment. Now this make payment is one of the client APIs, I would say. So if you think about this in a client server architecture, the backend team would develop this endpoint, make payment, right? This could be an handler in that case, and this API endpoint would be passed on to the client side, and the client would be making use of this make payment API. Okay, so the from a client perspective, it is only aware of two functions. One is the new payment gateway, and second is the make payment. Okay, and just by using these two APIs or these two functions, it will be doing the payment thing, right? All right. So how do I go about this? Now, what I can do here is essentially, so make payment, right? So let's do it. So from a client, what I'll do is first I'll have to instantiate a context object here. Now the context class here is the payment gateway. So let's say payment gateway, and I'll pass two things here. One is the name, right? So let me call this as the PG1, or let's say, so payment gateway would be like bill desk, or if you have used all these payment gateway apps, it will be bill desk. Let me call this as bill desk. It could be, you can give another name also, right? Razorpay is another example for payment gateways, and the other one would be the second parameter is the method option. Now here I would pass, let's say, UPI. So I'll call this as a UPI, right? So I'm passing these options as the this thing. So I'll say PG is equal to new payment gateway. So let me call this, okay, sorry for my, it's my bad, I'm essentially directly instantiating the object here, but this is not the way. Essentially I'll call the constructor here. So I'll say new payment gateway, and I'll pass the names. So I'll say bill desk, right? And the second option is to pass the object for the options, right? So this would be like UPI. So I'll call it as the UPI because I want to use the UPI option here, right? So this is how I'm creating a new payment gateway, right? Now this payment gateway, I can say that PG dot, now I have an option to make a payment, right? So I'll say that PG dot make payment. So if you look at here, I have a make payment option here, which wherein I'll pass the value. Let's say pass 20. So what should ideally happen? Now I should be able to make a payment using this UPI, right? I'll be using the UPI code. Let me just quickly run this code and show you that this is going to make a call to the UPI object. So if I say ls, all right. So if you look at this, it essentially calls pay 20 rupees using the UPI, right? Now let's say on the runtime itself, I want to make a change here, right? Now how do I do this? Now if you look at here, what I've done is while instantiating the object, I pass this as an object. So basically I'm infusing or I'm injecting one object of UPI class, right? Now you might wonder, this we're not doing it anything at runtime, right? We are all compiling it together because this is bound to be a part of this object, right? So we are basically infusing two objects together and forming a new object. So how is this runtime? Now essentially when you're doing this, this is not going to be at no, this is not how we are going to do it runtime. So this is not how you do it runtime. Not for to have this as a runtime behavior. What you can do here is you can introduce another function altogether, which will basically set this value right for you. Now, for example, I will say function. Okay, now I have introduced another function. Now this function is essentially a part of this class, right? So it's a class method. Okay, now what it does is it basically at runtime it takes a payment option as an input, and then it maps it to the method, right? The payment method of this class, right? Now I can use this choose payment method option, right, during runtime itself to basically swap between the different objects or different payment options, right? Now here what I did is I was basically tying up the object of UPI with the payment gateway. Now this was a static way of doing it. But now what I can do here is I can, on the runtime itself, I can say, so let's keep this example intact. Now if you see here, if I run this code again, it will again say that I'm basically making a payment using the UPI. Now at runtime itself, I want to make a change here. So what I'll do is I'll say pg dot choose payment option, and let's say here I will just change the name. So my name of the payment gateway would be the same, still the bill desk itself, but now let's say I pass the new object here. So let's say I pass the new object saying that credit card, right? So I pass this, and now I say pg dot make payment, right? And let's say I say again 200 this time. Okay, now if you look at this code carefully, initially we instantiated a payment gateway and we mapped UPI object into it, and we made a payment of 20. Now for the next transaction, we change it from UPI to credit card, and now we are making a payment of 200 using the credit card, right? So if you see here, I'm not changing anything statically, right? It's all runtime. So if I just open up this terminal and if I run this, so if you see here, on the fly, it just became credit card, right? Without changing it. Now this program is terminating because it's not running infinitely, but let's say this is a backend service which is running infinitely or for continuous hours, then these things can be injected from the client side itself, right? So from the client side itself, this can be injected. Now you might have another question. Does this mean that the client will have an option, or does this mean that the client will be aware of all the backend services like UPI, credit card, cash on delivery and all that? Not exactly, right? So when you're basic, so what you can do is you can essentially give the client these options as parameters, right? And based on the parameters, or this can be integrated in the GUI side itself, that they can choose among these options, and then if none of the options are implemented, then a particular option would be a particular error message would be raised out, right? But I think this clears the idea. But I think this clears the concept of the strategy design pattern, right? It's very simple, right? There's nothing fancy about this thing. It's the idea is very simple. I'll just reiterate again. The idea is very simple, that it allows you to choose algorithms at runtime, right? And how do I implement this? It's also very easy, that you just have to introduce a context class in between. For example, the way we had here, the payment gateway class, this payment gateway class will have a constructor, and the most important part is it will have an option. So this function, the importance of this function is that this injects the payment method at runtime, right? And this is the beauty of strategy design pattern. Now if you look at this code, right, let's talk about the credit card itself. Now if you look at this credit card as a object and class, they are basically an isolated function, or they're isolated entities, right? Now credit card is nowhere related to cash on delivery. So let's say in future I stop supporting credit card, right? So the best thing I can do is I can just simply remove this code, or I can remove the option to choose or instantiate this credit card. Anything is fine. But the idea here is that this removing or addition of any new service won't affect the other services. Now by this, you are making sure that your system is running in isolation and it is extensible, right? So this is what I wanted to convey here. All right. Okay. Now let's take another example just to cement this idea in your mind. Okay. Now let me just go to this cache option here, right? Now if you're familiar with cache, now cache also has multiple algorithms running within. For example, a cache can implement an LFU algorithm, which is the least frequently used element. So these are the cache eviction policies, right? So how, when a cache gets full, using what algorithm it should clear the existing elements in the cache so that it makes room for the other new elements to come in, right? So now cache has multiple options for this. One is LRU, which is the least recently used. One is FIFO, first in first out. Then you have LFU, and then you have a random option, right? So you have multiple options of doing this. So if you look at this algorithm again, or this, if I want to design a cache system in whole, so now if I want to design a cache as a system, I would again go for a strategy design pattern, because again I have an option of choosing multiple algorithms at runtime. Okay, now a very classic example for this would be a Redis cache, right? A Redis cache has multiple cache selection policies, and you can also tune these algorithms at runtime. Okay, so for example, let's get into here. So for example, here we have a eviction algorithm. So I've just called this interface as eviction algorithm, and it only has one function. Again, in reality, it can have multiple methods, but for sake of simplicity, I'm keeping it as one algorithm or one function, I would say, which is the evict function. Now I have one class called as the LRU, which is implementing the evict function, right? Then I have an LFU function, or the LFU class, which is going to implement this. Then I have a FIFO. So essentially I have three different sort of classes, right? So if you look at the UML diagram which I drew here, so for people who are not aware, this is the UML diagram which I drew in a very rough sense. Okay, I have not used the exact nomenclature or the terminologies used in a UML diagram, that I'll show you in the end, but that was a rough idea. Okay, that is just a rough diagram to explain you. Now again, coming here, let's try to understand this. So what I've done here essentially is I have created three classes. So one class is called as the LFU, another one is called as the LRU, and the third one is called as the FIFO. So I have three separate classes. They'll all have separate functionalities. They're all modular, or they're all independent of each other. All of the three inherit the same interface called as the eviction algorithm, right? So I call this as the eviction algorithm, and it is an interface type. So this is the symbol I'm using for interface, and all of them are basically implementing the same set of this thing, interface. Now I'll have a context class, right? So now let's go back to the context class here. Let's see the code. So here, if you see here, I have a cache. Now this is going to be my context class. So it has got a name and it has got an eviction algorithm, right? Now again, it is also using the interface itself so that it becomes plug and play, right? Now again, I have a new cache as the constructor or the factory method here, which again takes the same set of things. It takes the algorithm and it also takes the name. Okay, and now I have a function called as set eviction algorithm. Now this algorithm or this method is important because this will allow us or the client to inject the algorithms at runtime into the context object, right? And then I have a display function which basically displays the which algorithm I'm using currently. Okay, very simplified, very superficial algorithm, but yes, this is all about, but yes, this is to explain you how a strategy pattern can be employed in your code, right? Now, so from the client or from the main function itself, I'm making a new cache here, and initially I'm just assigning a random, or not a random one, but with some initial value, right? So my cache would have a initial algorithm as LRU. Now if I call the display, it will display that which algorithm it is being used. And now if I evict, so it will say that okay, which algorithm it has used to evict the elements, right? Now this is interesting that while I'm executing, while my cache is still running, I can simply set the set eviction policy to FIFO. So from LRU, I'm shifting it to FIFO, and now if I say now evict, it will start evicting using the FIFO technique. Okay, so just to demonstrate. All right, so if you look at this eviction using LRU caching, which was the first technique, and then it's saying eviction using the FIFO caching. Sorry for this typo, but I think I have made a typo mistake here. Using spelling is wrong, so let me just see this, replace this with using. Okay, so I think I've fixed that thing, but yeah, this is the whole idea here, right? So if I come back to my diagram again, so what I've done here is so this part is clear, right? Now what I've done is I've essentially created a context here. So this is my context, and this is nothing but the cache which I'm talking about. And now from the main, I'm essentially calling along with the algorithm which I want to use, and this cache context is basically replacing that. Now again, this is very simplified and simple example. It might bring its own challenges, but this is the whole idea in a very nutshell, that how you can arrange a code or your program so that it becomes more extensible and maintainable, right? Now, if you have watched my previous video, for which the link I'll put in the description also, regarding state design pattern. Now, you might get confused that what is the difference between a state design pattern and then strategy design pattern, because if you look at the state design pattern, in that we're also moving from one state to another. That means we are moving from one set of algorithm or from one set of objects to another object, right? So you have to understand that there are a couple of differences between these two design patterns. First of all, you can think of that in a state design pattern, the states are aware of each other, right? So when you're moving from one state to another state, the state knows, a state A knows about state B, a state B knows about state C. So the states are very well aware of the known other states, right? How they're aware of this is through an indirect uh, movement. Basically, there's a transitive relationship because the context class there has the references for all the other states, right? If you're not aware of it, you can just go and watch my state design pattern also, but that's the idea. So there is a sort of awareness, indirect awareness at least. In strategy design pattern, it's not so, because if you look at all these classes are all independent of each other, right? FIFO class has nothing to do with the LFU class, the LRU cache, right? So they're all independent of each other. That's one major difference between these two, right? So, and this makes it extensible, right? And in state design pattern, you're essentially moving from one state to another. So every state is implementing the same set of functions, just like the way we are doing here also, because both these state design patterns, in both the design patterns, we are implementing an interface, right? But here, what we're doing is once we switch from one, so here we are not switching states. Here we're switching algorithms. So the machine might not be in the different states. And I think that's the major difference between these two, right? In a state design pattern and in a strategy design pattern. Another major difference is a state design pattern. There is an internal state in the form of the finite state machine, whereas in a strategy design pattern we don't have such state machines, right? So we are good with that, right? And if I talk about the other differences, let me just open up the readme file also. Okay, before getting into there, let me also show you the formal UML diagram, right, which I just drew here. So let me just make it big. So if you come here, this is how the UML diagram looks like, right? So you have a concrete implementation, which is behavior one, which is the algorithm one, you can also call it as that way. Then you have a strategy behavior two, which is again a concrete implementation, and both of them are implementing from a interface, which is going to be a strategy interface. So I'm just showing you this UML diagram so that you can, if you want to go and read about this on the internet, you have a solid understanding that what these terms are. All right. So both of them are implementing the strategy interface. And now, so if programming languages support inheritance, you can say that they're implementing this interface. And then we have this context class. In this example, we have a cache. So this is the context class, and this context class has a relationship with the interface, right? So this is a has a relationship because the object, the set strategy algorithm, right? This is that function. This basically switches the objects for the concurrent implementation. So this is a has a relationship between them, and then you have the client code, which is basically talking to this context class, right? So yeah, I think this is all about the strategy design pattern. I hope you learned something new. If you did, just please subscribe, and till then, bye bye.